All right, ladies and gentlemen, welcome back. Last time we talked about the electromagnetic spectrum. All that is talking about light, okay? All that is light, different kinds of light. This is the visible spectrum, range from red to purple here. And the red, these numbers here are in nanometers, which is times 10 to the negative 9, okay? So whatever that number is, let's say red is 650 nanometers, that's 650 times 10 to the negative 9, and that's our wavelength. That is our wavelength. The symbol for that is upside down Y. It's the lambda. It's getting blurry here, so let me put the actual paper on here. Okay, focus. Okay, so this equation involves speed, frequency, and wavelength. We're just going to focus on two things. We're going to focus on frequency and wavelength. We're not going to worry about speed. All right. Speed of light. Well, speed of light. Speed of light is constant. C is always 3 times 10 to the positive 8 meters per second. That is the speed of how fast light travels. It is a constant. It's always that number. 3 times 10 to the 8. Okay. And C is equal to V times lambda. V in this case, V is equal to frequency. Frequency sometimes, I think one is in Latin, one is in Greek. I think F is sometimes used for frequency as well. So in our flame lab test, we saw F as frequency, and that's perfectly fine. And the unit for that is hertz, which is how many waves per second. So waves per second, so it's second to the negative 1. That is the unit for that, is waves per second. Number of waves that pass through a given second. Oh, here it is, sometimes F. So the definitions are up here for you. Pretty good. Okay, so the math is fairly easy. So C equals V lambda, okay, or F lambda. Let's use V in this case, all right? The wavelength, so we have a wavelength of that is your lambda. What is this frequency? So we know what C is already. What if we want frequency by itself? We have to do a little algebra here. V by itself, we have to divide by lambda on both sides. Divide by lambda. So frequency, that cancels out. Frequency equals C divided by lambda. C is 3 times 10 to the 8. Remember, C is a constant, meters per second. Lambda is the wavelength, which is, the wavelength is 4.10 times 10 to the negative 12 meters. Negative 12 is even smaller than nanometer. This is really, really small. So let's punch that in. When you punch that into the calculator, ladies and gentlemen, please make sure you put parentheses around the denominator, or else what it's going to do is it's going to divide by 4.1, and then it's going to multiply by 10 to the negative 12, and you're not going to get the right answer. Okay, so I have my calculator here. I'll punch that in. 3 times 10 raised to the 8. Okay, divide, open parentheses, the bottom number, 4.10 times 10 raised to the negative 12. Then I have to close that parentheses. Make sure you close that parentheses and hit enter. Voila! You see that 7.3, we'll write to 232 times 10 to the 19th. That e to the 19 means 10 to the 19. That's that E19 right there. Okay, that's what that is. So when you write it out, it's times 10 to the negative 19, and the unit is hertz, Hz, and that would be the frequency. Okay, so your turn now. There's a wavelength. Now it's a microwave, 6 centimeters. 6 centimeters here is 6 centimeter is how many meters? You need to change this to meters. So 6 centimeter is divided by 100, so 0.06 meters. That is equal to your lambda. Okay. This one's a little easier. Okay, so that's your lambda. All right, let's just do it anyways. Just more practice here. You can do 2 on your own in a little bit down here. Yeah, let's do that. Actually, oh, I have it here. 6 meters. Actually, I want you to actually do this because this is the last question on here that determines frequency. So do your calculations, and I'm going to do it as well. Pause the video, do the calculations, and then continue. Okay. All right. Now you should have done number 2 already, and you'll see number 2. Number 2 is 3 times 10 to the 8 divided by 0.06. So this one you should have 5 times 10 to the 9th hertz. 5.0 times 10 to the 9 hertz. That should have been your answer. If you did it good, then you did it correct. You got that good. So V is equal to C over lambda. C is 3 times 10 to the 8 divided by 0.06. There's no scientific notation on that. There is if you want, but that should have been your work there, and you should have gotten 5 to the 9. Did I type it right? 3, let me try that again. 8 divided by 0.06. 5 times 10 to the 9 hertz. Yes. So notice the difference here. The key point we want you to get out of this unit, this lesson in this class, is that look, you have a low. This is short. This wavelength here is shorter than this. This is longer. Longer wavelength. This is shorter. Because this is 0.000000 with 11 zeros in front, and this one only has 1 zero. Longer wavelength. Guess what? Look what happened to the frequency. Longer wavelength, lower frequency, lower frequency. Let's switch back to F because it makes more sense with F is frequency. Okay. So shorter wavelength this is higher frequency. Higher frequency. Okay. So that's the point we want you to get there, right? So you see that again down here. So you should be able to do, what is the wavelength? So now we're trying to find wavelength. Remember, C is equal to lambda F. Let's try it. C equals lambda times F, right? So now if I want wavelength, guess what? Divide by F on both sides. C divided by F, I'm mixing up here, equals lambda. C divided by F equals lambda. So lambda equals C divided by F. So if you want to find F, you want to find frequency, C divided by wavelength. If you want to find wavelength, it's C divided by frequency. Same thing. So C is still 3 times 10 to the 8. The frequency here we have 8 times 10 to the 14 hertz. Meters per second. You can have units. Units not too important here, but just so you know. So now we type that in the calculator. 3. Remember, anytime you divide, put parentheses around the number on the bottom. 3. I'm gonna take a shortcut here. I'm gonna type instead of times 10 to the negative 8. There's that little button EE down here next to the A. Right here. Next to A, there's that EE button. Just type that instead of right times 10. So 3EE8. See, instead of times 10 to the 8, I can type that. Divide by 8e to the 14. See, I don't need to use parentheses if I do that. And voila, I get 3.7. 3.75 times 10 to the negative 7. And this is a wavelength, so that's meters. So ladies and gentlemen, remember that e to the 7, you don't write that out. When you write out, you write like this, 10 to the 7. Okay. So on your calculator, it says 3.75 e to negative 7. You convert it, you write it as a normal number like that. Because people don't write this. That's calculated. Okay. So you should be okay to try that next question there. And I think that's all we'll do. So you'll go ahead. You should be able to do number 3 and number 5. Should be able to. You do number 3 and number 5. And the next page. However, we're not going to touch on the energy part. We're going to go do away with the energy part, but I just want you to answer number 9 and number 10, okay? Number 9, number 10. So parts of a wave. Calculate the parts of a wave. Here's the label the amplitude and the wavelength. Wavelength is basically pick one part of one wave and go to the next one. This is your wavelength. Okay. So that is your wavelength. It's from any point on one curve to the same point on the next curve. So the amplitude is basically just the height of the wave. It's from here to here. Okay. That's not important though. Just focus on the wavelength part. Okay. And so calculate the frequency. Remember, frequency equals waves per second. So basically waves, number of waves divided by seconds. How much time is going through it? How much time is this? Look, it says you 0.1 seconds. So you go 0.1 second goes down here. How many waves do you see? 1 and 2. You see 2 waves. Let's take 2 divided by 1 second. Take 2 divided by 1 second, and you'll get 20 hertz. All right, calculate the frequency. That would be 20 hertz. Cool. How many waves per second? What is the relationship between frequency and wavelength? We discussed that in the previous part. The previous part is, remember, high frequency equals low wavelength. Low frequency equals not low, short. It's weird. It's low, and low frequency is equal to long wavelength. Because the longer wavelength means it's going to happen less. It's going to go slower and slower. You have really short wavelength. It goes like that. Look at that. 1 second. It's going to go a lot faster. It's going to have higher frequency, shorter wavelength. So your red light earlier will have a longer wavelength, so it's higher frequency. It's lower frequency. Longer wavelength, lower frequency. Your purple light will have shorter wavelength and higher frequency. So they are opposite. They are opposite. That's what we call an inverse relationship. Okay, an inverse relationship. Inverse relationship. But I'm going to go ahead and explain this last one too. What is the relationship between frequency and energy, though? Frequency and energy. So high frequency equals high energy. Low frequency equals low energy. So energy and frequency go hand in hand. They both go up at the same time. So in math, if you have a line that goes up with a positive slope in a constant increase, that's what we call a direct relationship. Okay, a direct relationship is when one goes up, the other goes up. So kind of like as you grow up, what happens to your weight? Your weight goes up with it, right? As you get older, weight goes up. One goes up, the other goes up. Something else that one goes up, the other goes down. Inverse is one goes up, the other goes down. Is what? The more stuff you buy, the less money you have, right? That's another concept, a way to think about it. The more stuff you buy, the less money you have. The more you work, the more money you have is direct. You work 5 hours, you have more money. You have 10 hours, you have even more money. So as one increase, the other increase, that's direct. If one increase, the other decrease, that is indirect. So understand just that concept, that idea of inverse and direct relationship, and that's perfect. Thank you so much. Enjoy your time. Enjoy your day. Happy studying.